Good morning, students. Say your prayer. தேங்க்யூ. நான் ஒரு நல்ல ஆசிரியர். நான் உங்களுக்கு தாயாகவும் தந்தையாகவும் முறையாக அன்போடு கல்வியை போதிப்பேன். நான் ஒரு நல்ல ஆசிரியர். நான் உங்களுக்கு தாயாகவும் தந்தையாகவும் முறையாக அன்போடு கல்வியை போதிப்பேன். நான் ஒரு நல்ல ஆசிரியர். நான் உங்களுக்கு தாயாகவும் தந்தையாகவும் முறையாக அன்போடு கல்வியை போதிப்பேன். So take your social science book. So take page number 147. Today we will discuss about earthquake. So how earthquake occurs? So due to endogenic force. Okay, so before entering into the class, so just to recall what we have discussed in our previous class. In our previous class, we discussed about the interior of the earth. So what are the three layers of the earth? Yeah, crust, mantle, then core. Yeah. So which is the outermost layer of the earth? Yeah, crust. Okay. So how was the crust divided? Yeah, continental crust, then oceanic crust. Then we saw about the composition of the crust, then the density of the crust we saw detailedly. Then we discussed about mantle. So the layer which is lie below the crust is called as mantle. Then we saw the density of the mantle and how was mantle divided. So mantle is divided into two parts. We saw detailedly. Then core. So how was core also called as? Yeah, barysphere. So barysphere is the other name for core. So core is also divided into inner core and outer core. Then when compared with the crust and mantle, core have the highest density. So we saw that also. Then the earth movement, that is the lithosphere, that is the surface of the earth is broke into many plates. So and that plates are moving independently over the asthenosphere. So we saw that detailedly. Then so these plates collide with each other, or sometimes these plates move away from each other. Yeah. So we discussed that also. Then finally we saw about the two forces, so which causes change in the surface of the earth. One is called as endogenic forces and another one is called as exogenic forces. So endogenic forces, the force that acts from the interior of the earth, so like earthquake, volcanoes, etc. So they are called as endogenic forces. So exogenic forces means like river, wind, waves, etc. So that causes change in the surface of the earth. Okay, ma? So we discussed about them in our previous class. In this class we will discuss about earthquake, so one of the endogenic forces which cause change in the surface of the earth. Okay, so let us move into the lesson. So what is an earthquake? So earthquake is a sudden movement of a portion of earth crust which produces shaking or trembling. So we are in the crust. So earth is divided into three layers now: crust, mantle, core. So we are standing on the crust. Yeah. If there is any sudden movement in the portion of earth crust, so that produces shaking or trembling. So trembling means so shaking that you can't control. Okay, so sudden movement of a portion of earth crust which produces shaking or trembling. So the earth crust is broken into many plates. So the lithosphere is broken into many plates, so which is shown in this map. So these plates often float over the asthenosphere. So these plates float over the asthenosphere. So when these plates collide means, or sometimes it move apart means, sometimes it cause vibration which was feel on the surface of the earth. So that was called as earthquake. So earthquake may cause widespread damage to life and property. So earthquake cause a lot of damage to life and property. So what is an earthquake? So earthquake is a sudden movement of a portion of earth crust which produces shaking or trembling. So we are in the crust. So earth is divided into three layers now: crust, mantle, core. So we are standing on the crust. Yeah. If there is any sudden movement in the portion of earth crust, so that produces shaking or trembling. So trembling means so shaking that you can't control. Okay, so sudden movement of a portion of earth crust which produces shaking or trembling. So the earth crust is broken into many plates. So the lithosphere is broken into many plates, so which is shown in this map. So these plates often float over the asthenosphere. So these plates float over the asthenosphere. So when these plates collide means, or sometimes it move apart means, sometimes it cause vibration which was feel on the surface of the earth. So that was called as earthquake. So earthquake may cause widespread damage to life and property. So earthquake cause a lot of damage to life and property. Then the point where the vibration originate, that is the point where the earthquake originate, is called as the focus of the earthquake. Okay, so the earthquake causes vibrations in the earth crust. So it shakes the crust. So the sudden movement causes some vibrations on the surface of the earth. So these vibrations where it originates, so the point of originate of vibration is called the focus, and the point where we feel the earthquake, that is the point of earth surface directly above the focus, is called the epicenter of the earthquake. So focus is the origin of earthquake, epicenter is the place where we feel the earthquake, that is epicenter is the surface of the earthquake. So from the focus, the earthquake vibrations travel in different directions in the form of seismic waves. So the earthquake originate in the focus region, so that is the vibration starts in the focus region and it travels in different directions, so in the form of waves, in the form of seismic waves. So it can travel in any direction. So it can travel in any direction, and we feel the earthquake waves in the epicenter. The earthquake waves are measured by an instrument known as seismograph. So we saw that earthquake means waves. So seismic waves traveling from focus to epicenter. So these seismic waves are measured by an instrument known as seismograph. Then the magnitude of an earthquake is measured by the Richter scale. So the level of the earthquake, so that is the magnitude, the scale of the magnitude of earthquake is measured by an instrument, by a scale called as Richter scale. Then the number of the scale ranges from 0 to 9. So the number of the Richter scale ranges from 0 to 9. So seismograph, so which is an instrument used to measure the earthquake waves, that is seismic waves, and the magnitude of an earthquake is measured by the scale called as Richter scale. The number on the scale is ranges from 0 to 9. So what causes earthquake? So we saw that the movement of earth crust, so that is a sudden movement of a portion of earth crust, so that produces shake or trembling, which is known as earthquake. So what causes the movement of the portion of earth crust? Then what is the chief cause of earthquake? So the chief cause of earthquake is the sudden slipping of the portion of earth crust along the fractures or fault. So that is the earth crust is broken into many plates, we saw. Okay, so if there is any sudden slipping over the fault or fractures, that is if there is any sudden movement in the plate, so if there is any sudden movement in the plate where the plate meet together, or where the plate collide with each other, there we feel earthquake. So earthquake was not feel in the all regions. So mostly earthquake felt in the region where the plate meets. So the earth is divided into many plates now. Wherever the plate meets, so there is a chance for earthquake. So what causes the movement of this earth crust? What causes the movement of these plates? So there is molten rock. So in the mantle region there is the rock which is in the molten form. So in that molten rock only our crust floats over. So the heat from the interior of the molten rock so causes the plates to float over them. So sometimes if the plates float over means these plates collide with each other, so that cause vibrations among the surface. Or sometimes if the plates collide with each other means one plate goes down and another plate moves up. So it takes place between the oceanic plate and continental plate. So that continental plate moves upward means, so we feel earthquake in the continental region. Or if the two continental plates collide with each other means it moves up. So it also causes earthquake. Okay, so the movement of the molten rocks, so in the mantle region, so produces a strain which breaks the rock apart. So this movement so sometimes causes vibration, so which break the rock in the surface region, so that we feel as earthquake. Then the sudden shifting of land mass causes upheavals in the crust of the earth, sending vibrations or waves into the surrounding portions of the earth. So sometimes these plates suddenly shift, so suddenly move, so that also cause vibrations in the crust, so which was experienced as the earthquake. So sometimes the surface of the earth itself cracks, so the mantle region contains in the molten rocks, so which releases heat energy, okay, so heat energy. And also these molten rocks, since it is in the molten state, the crust floats over this molten state, so the crust region floats over this molten state and often collide with each other. So the plates collide with each other, so that causes vibration which was felt on the surface of the earth crust as earthquakes. Okay, so the main cause of earthquake was the movement of the plates. So why the plates was moving, so why the plate was floating means because it floats over the liquid, so molten state, so molten rocks. Okay, so that's why there is a chance of earthquake. So this image simply shows the earth crust, the movement. So from left to right, so see, first the two continental crust, two plates collide with each other. So it rises up, so that the fold mountains are formed. Then see the earth crust in the ocean floor. So for two plates move apart means, so the magma from the interior of the earth comes out, so and spreads over the sea floor. And if the ocean crust and the continental crust collide with each other means, so the ocean crust so goes down, so down going slab, and the continental crust moves up, so it results in the release of magma, so release on the magma in the floor between ocean and continent, so volcanic mountains. So these are the things so which cause vibrations. So if this activity occur means it causes vibrations, so that was felt on the surface of the earth. So from this picture you can understand, you can guess that the earthquake occurs in the region where the two plates meet. So where the two plates meet, so there is a chance of earthquake. Then effects of earthquake. So earthquake may cause changes in the earth surface. So earth surface went a lot of changes, so because of earthquake. Okay, so it result in a variety of changes. Okay, so vibrations often cause landslide in the mountainous region. So if earthquake occurs in the mountainous region means it causes landslide. So look at this picture. So because of an earthquake, so the transport facility was affected. So apart from this, there are a lot of changes that occurs in the mountainous region. So the main cause is it causes landslide in the mountainous region. Then another important effect is the falling of buildings. So if it took place in the flat area, that is in a plain or Deccan area, plateau area means it causes the falling of houses. So houses were collapsed. So houses collapsed which was built of mud and bricks. So the houses were built with the help of mud and bricks means it was easily collapsed, it was easily fall down. Then so these buildings were proved to be death traps. So the buildings which were constructed with the help of mud and bricks were proved to be death traps. Another important danger is fire. So there is a chance of getting fire. Then notable one is underground water system is naturally disturbed. So there is an earthquake occur means, so it disturbed the underground water. So first it causes the falling of buildings, then second proved to be death traps. So the buildings which was made of mud and bricks were proved to be death traps. Then there is a chance of getting fire. So there is a chance of getting fire. Then fourth one, underground water system is disturbed. So underground water system was disturbed. So first falling of buildings, that is the houses made of mud and bricks were collapsed. So which proved to be death trap. Then fire. So there is a chance of getting fire. Then last one is underground water system is naturally disturbed. Then another important effect of earthquake was tsunami. So an earthquake which originates below or near the sea causes great disturbance in the water. So the floods and waves cause great loss of life, sometimes more than the earthquake. So tsunami, it is a Japanese term, so which is the name given to the huge waves caused in the sea by an earthquake. So tsunami, the name given to the huge waves caused in the sea by an earthquake. So if there is an earthquake occurs in the sea means it may cause tsunami. Yeah. So how means if two plates so meet near the meet in the ocean floor means okay. So if there is any two plates, if there is plates meeting in the ocean floor, so if these plates move apart means so there is a huge pressure so that comes from the interior of the earth that pushes the water, and the water comes to the coastal region as tsunami waves. Or sometimes if the continental plate and ocean plate meets in the ocean means so collide with each other means so the ocean plate goes down, so it moves down, and the continental plate moves up so that it pushes the water up that comes to the coastal region as tsunami waves. Yeah. So I will show you this how tsunami occurs in a video. So at the end of this lesson, so you can note the video. So at the end of this lesson, you can see two videos. So one is about how earthquake occurs, and another one video so how the tsunami waves formed. Okay, va? So the tsunamis are quite often seen in. So the tsunamis are quite common along the coast of Japan and other regions in the Pacific Ocean. Yeah. So tsunamis are commonly seen in the coast of Japan. Okay, va? Then so in India, so we faced a tsunami in the year 2004, 26th December 2004. So India experiences tsunami. Okay, ma? Then distribution of earthquake. So where you feel earthquake. So we saw wherever the plate meets, so there is a chance of earthquake. So wherever the plate, so the continental plate meets, so continental oceanic plates meet, so there is a chance of earthquake. So the world's distribution of earthquake coincided very closely with that of volcanoes. Yeah. So wherever the volcanoes are there, so there you can see the earthquake. Okay, ma? Then so regions of greatest seismicity are circum-Pacific areas with the epicenters and the most frequent occurrences along the Pacific Ring of Fire. Yeah. So the most frequent occurrence of seismic activity, earthquake activity was circum-Pacific areas, especially in the Pacific Ring of Fire. Yeah. So totally 68% of earthquake occurs in this belt, that is in the Pacific Ring of Fire belt. Yeah. Then remaining 31% earthquake takes place in the Mediterranean Himalayan belt, including Asia Minor, the Himalayas, and parts of northwest China. So 31% occurs in the Mediterranean Himalayan belt. Then the remaining percentage occurs in the northern Africa, Rift Valley areas of the Red Sea and Dead Sea. Yeah, so remaining percentage occurs in the North Africa. So this map shows the seismic distribution. So the world under the circum-Pacific seismic distribution. So you can find Pacific Ocean at the center of the map. Yeah. So around that there are a lot of red color, dark line, red mark now. So that is called as the Pacific Ring of Fire. Okay, ma? So in this region only 68% of the earthquake occurs. Then remaining 31%. So just locate India. So can you locate India? So just above Indian Ocean. That is from the left. So Africa, Arabia, then India. So that region also experiences a lot of earthquake. So from the northern part of Africa, so that is in the Mediterranean region to Himalayan belt. So there is a lot of earthquake. So that is 31% of earthquake occurs in this region. Remaining 1% occurs in the other region. Yeah, so mostly 68% of the earthquake occurs in the around the Pacific Ocean. Okay, so in this Pacific belt only there are several plates meet. Okay, so American plate, North American plate, South American plate, then Pacific plate, Eurasian plate, Australian plate. So all of them met in the Pacific Ocean. So that's why there is a lot of earthquake and volcano eruption occurs in this Pacific Ring of Fire. The earthquake in India. So already we saw, so Himalayan belt is prone to earthquake zone. So in India, so Himalayan region is often prone to earthquake zone. So, so in India, the Himalayan region under the Ganga Brahmaputra valley were prone to earthquakes. Okay, so why means, so India was a part of Indo-Australian plate. So India was a part of Indo-Australian plate and Eurasian plate. So Asia is here in the Eurasian plate. So India plate, so Indo-Australian plate, so collide with the Eurasian plate. So sometimes it causes vibrations. So Indian plate, so collide with it is moving towards Eurasian plate. So that's why there is a chance of, so there is a occurrence of earthquake in the Himalayan region. So sometimes these earthquake were very severe and causes extensive damage. So for example, the earthquake in Uttarkasi, so it is in Uttarakhand. So can you locate Uttarkasi in this map? Uttarkasi. In 1991 there is an earthquake, and in 1999 there is an earthquake in Chamoli. So both causes a lot of damage. Okay. So mostly earthquake occurs in the Himalayan region only in India. But at sometimes the Deccan Plateau also experiences the earthquake. So Deccan Plateau, so comparatively free from the dangers of earthquake, but there are two severe earthquakes occur in the Deccan region also. So Deccan Plateau, which is comparatively free from the earthquakes, so also experiences two severe earthquakes. So one is the Koina, so which is in Maharashtra earthquake, which is in Maharashtra, and in the Latur, so which is also in Maharashtra. So you can find in this map, so in Maharashtra you can find Koina and Latur, so which is in the Deccan region. So it also experiences earthquake. So in Koina, the earthquake occurs in the year 1967, and in the Latur, so the earthquake occurs in the year 1993. So it causes severe damage. So earthquake not occurs only in the Himalayan belt, it also occurs in the Deccan region also, but it occurs rarely. Okay, but in Tamil Nadu, so there is a less chance for earthquake. So because there is no plate that meet in the Tamil Nadu region, in our region. So already we saw wherever the plate meets, so there is a chance of earthquake. But don't think so earthquake only occur in the place where the plate meets. Sometimes the vibrations will travel in different directions. Or sometimes there is a chance of formation of new plates. So because of the molten rocks, so there is a chance of breaking of formation of new plates also. So we know that is initially there is only one plate, so there is only one continent. Now it broke into many plates now. So there is a chance of earthquake in future also. Okay, va? So see this picture, students. Is it man-made? No, it is an earthquake. So when the two plates so move apart, means it form a deep trench, a deep hollow like this only. So this can be noticed in Africa. So in the northeast part of Africa, you can notice such rift. Okay, this type of fracture is called as rift. It occurs when two plates move apart. Okay, so okay, students, today's class over. So we discussed about earthquake in detail. So continue this, I will attach two videos, so just listen at this. So one is about earthquake and another one is about the tsunami waves. So if you have any doubt, so just contact me. So for textbook reading, so today take page number 147 and read the effects of earthquake loudly. Okay, then after reading, finish your homework. So I will send the screenshot of the homework, so following this video. Okay, so thank you. Have a nice day.
The ground starts to quiver, glasses rattle. Soon walls shift and everything begins to collapse. Telltale signs of what could be a devastating earthquake. We've seen the destruction they unleash. Some of us may have even lived through one. And we know they can be deadly. But where does this mountain-moving force come from? While we may think we're standing on solid ground, the Earth beneath us isn't completely stable at all. Our planet's crust is made up of about 12 major tectonic plates that fit together like a giant jigsaw puzzle. These huge slabs of land float on superheated magma and constantly shift, bump, and grind against one another. It's there, along the seams, where earthquakes tend to happen. When friction between the two plates is violent enough, seismic shock waves ripple through the ground, rattling everything that stands on it. The stronger and shallower the quake, the more violent the destruction. The most violent type of earthquake is born in a subduction zone, where one tectonic plate is shoved beneath another. While one plate is forced downward into the mantle, the other juts upward, often violently. This is the type of quake that rocked Nepal in May 2015. And when subduction happens under the ocean, it can create giant, unstoppable waves called tsunamis, like the ones that killed hundreds of thousands in Japan and Indonesia. On average, earthquakes kill about 10,000 people each year. Sometimes numbers are far higher. The quake that hit Haiti in 2010 killed more than 300,000 by some counts, making it one of the deadliest on record. It is estimated that there are 500,000 detectable earthquakes in the world each year. 100,000 of these can be felt, and 100 of them cause damage. That's about 0.1%. The magnitude of an earthquake is measured using the Richter scale, which runs from 0 to 10, 10 being the strongest. Every whole number increase on the scale means 10 times more ground motion change. In recorded history, the world has never experienced a 10 on the Richter scale, but scientists predict an average of at least one major quake of magnitude 8 or higher every year. The fact is, the Earth's crust is restless and always on the move. We can't see earthquakes coming, but we can prepare for them. Engineers are now designing stronger buildings resilient enough to survive a direct hit. Scientists are crunching data to project the power of future quakes and anticipate when and where they could strike next. Right now, we can only estimate the probability an earthquake will occur, but perhaps one day we will learn to predict them, minimizing their destruction and saving countless lives.
All across northern Japan, they felt it. A violent magnitude 9.0 earthquake on March 11, 2011. It was centered about 80 miles offshore, and tsunami warnings went up immediately. In coastal cities, people knew what to do next: run to higher ground. It's from these vantage points on hills and in tall buildings that incredible footage was captured. In Kesanuma, people retreated to a high-rise rooftop and could only watch in horror as tsunami waves inundated their city, knocking buildings into rubble and mixing into a kind of tsunami soup filled with vehicles, building parts, and contents. Seawater cascaded over sea walls and into cities. This video shows the water rushing over an 18-foot seawall into Kamaishi City. The seawall here was the world's deepest and largest, but not enough for the magnitude of the March 11 disaster. It was the largest quake ever known in Japan, and one of the 5 largest recorded in the world. More than 28,000 people are confirmed dead or missing. When two tectonic plates push together under the sea, the resulting earthquake sends an enormous burst of energy up through the ocean, displacing enormous quantities of water. With the upward motion, a series of waves expands in all directions. In deep water, these waves travel fast, up to 500 miles an hour, but only reach a height of a few feet. A passing ship might not even notice. But as the waves enter shallow waters, friction with the ocean floor lowers the waves' speed, but raises their height. This video is from a Japan Coast Guard ship confronting a tsunami wave in shallow water on March 11. And a rare view from the air, video of a tsunami wave approaching the shoreline. In Japan, some tsunami waves reached as far as 3 miles inland. Japan may be the most seismologically studied country in the world, and with more than 1,200 high-precision GPS stations, a geophysicist at the University of Alaska used the data to create a visualization of the March 11 quake. The waves of displacement that you see were moving as fast as 5 miles per second. In this photo, the ripples of tsunami waves are seen moving upstream in the Naka River at Hitachi-Naka City. New technology left an enormous amount of visual evidence for study in years to come, and can perhaps help us better understand the power of earthquakes and tsunamis and prevent loss of life in the future.